So now let us talk about the properties exhibited by the charges, and along with that we shall try to compare it with mass wherever possible. Charge is an electrical property of the matter, whereas the mass is the gravitational property. So first point is that charge is said to be the electrical property and mass is said to be the gravitational property of the matter. There are two kinds of charges, namely positive and negative, as we have already understood that it was Benjamin Franklin. Benjamin Franklin introduced the concept of positive and negative because when he observed that these two kinds of charges has got a tendency to cancel the effect of each other. The one charge was that charge which was possessed by the electron, the other one is which is possessed by the protons. And when he introduced the concept of positive and negative, then electron was incidentally assigned the negative sign and proton was assigned to be the positive sign. And we know that it is just a matter of chance that negative was given to the electron. So there is no logic behind that. But in case of mass, we know mass is always only one type and which is positive. We are all aware of this fact in our life that like charges repel each other and unlike charges attract each other. There is nothing new about it. Do you agree with me? Of course, like charges repel each other and unlike charges attract each other, whereas in case of mass, it is always a case of attraction. As we know that the objects, because of their masses, attract each other. But in case of charges, it is attraction as well as the repulsion. The next point is the charge is additive by nature. That means in a body, total charge can be calculated by the algebraic sum of all the individual charges considering the positive and negative sign. Suppose there is a system of charge and there is one charge plus 2 microcoulomb, another charge is that minus 1 microcoulomb, another charge is 3 microcoulomb, there is one more charge minus 2 microcoulomb, then what is the net charge? So net charge on this system can be calculated by the algebraic sum of all the individual charges, but we have to consider the positive and negative sign. So here it is 2, here it is minus 2 gets cancelled and 3 and minus 1. So in all we have got a total charge of 2 microcoulomb in this system. So that is what is meant by the additive nature of charge. But in case of mass, as we know that it's always positive, it is of one type, so it is to be added always. So it can be said that it is also additive because it is always positive and all the numbers are to be added. But in case of charge, there is a difference. There are two kinds of charges. One is positive and the other one, the negative. So to calculate the total charge on the system, what will we do? Yes, we can find the algebraic sum of individual charges. How? By considering the positive and negative sign along with that. So that is how the net charge of any system can be calculated, and because of this additive nature of charge. So the next important concept is quantization of charge. The charge is quantized. What does that mean? Quantization means there is a minimum value of the charge that can exist, and total charge in a system will always be integral multiple of that minimum possible charge. As we know that charging process is carried out by the transfer of electrons only, so that minimum amount of charge is equal to the charge possessed by one electron, which we already know is 1.6 into 10 to the power minus 19 coulomb. So charge appearing on any object is due to the transfer of electrons, and electron has got this charge value. So the charge will always exist in the form of integral multiple of this electronic charge. As far as mass is concerned, we cannot say anything because we are not aware whether the mass is quantized or not. So quantization of mass is yet not established. And for the quantization of charge, as we have understood that charge will always exist in the terms of integral multiple of electronic charge, and charge on one electron is 1.6 into 10 to the power minus 19 coulomb. And when the object receives or gains the electron, in that case it achieves negative charge, and the object which loses the electron gains the positive charge. As we know that there is some mass associated with electron, which is 9.1 into 10 to the power minus 31 kg. So, do you remember that what I told, that whenever there is a charging process, in that case there is corresponding transfer of electrons, and so there will be a slight variation of masses. Do you remember that? So, tell me, what happens to the mass when some object gets negatively charged? Do you remember that? Yes, the negative charge means gain of electron. Gain of electron means the mass has to increase. So what is the amount of mass which increases? That can always be easily calculated by multiplying this number of transfer of electrons multiplied by mass of a single electron. Suppose n number of electrons are transferred from one body to the other, and one object which receives the electrons, its mass will increase by this amount. If we know that number of electrons transferred, then we can multiply it with mass of a single electron to calculate the corresponding change of mass. And in case of positive charge, as we know that it is a loser of electron, so its mass is going to decrease by this same amount. So, negative charge mass is going to increase, and positive charge mass is going to decrease in the transfer of electron process. So, therefore, the quantization of charge can be explained as the charge which can be transferred or may exist freely in nature will always be an integral multiple of the charge of electron, because the charging is done only because of transfer of electrons. Since electron is not a particle that can be cut into pieces, so it has to be the whole number. That number of electrons has to be an integer. So charge on a body can always be expressed as plus minus Ne, depending on whether it loses the electron or it gains the electron. And corresponding variation of mass will be calculated by the number of electrons multiplied mass of each electron. Negative charge will increase its mass, and the body with positive charge must have decreased its mass because of the loss of electrons in this process. The next important property is the conservation. Net charge of an isolated system. Net charge of an isolated system is conserved. Just be attentive. What are the keywords? One is isolated system, means there should not be any provision of transaction of charge with anything else. Then in that case, net charge of the system will remain constant. There is more to it. But for now, let me tell you that mass is not conserved. Have you seen this equation? The great Einstein was the name of the person who formulated this equation, E is equal to mc square. Meaning of this equation is that if we annihilate the m amount of mass completely, annihilate means destroy, means that much amount of the mass ceases to exist. In that case, the equivalent amount of energy which is generated is given by mc square, where c is speed of light. In nuclear reactions, what happens? There is a slight variation of mass, and because of that very slight variation of mass, even then huge amount of energy is generated, because we know that it is mc square. So from this equation we can understand that mass and energy are interconvertible. So we cannot say that mass is conserved, but in most of the cases we solve many questions assuming that mass is constant, because there is no such provision. But when you go into the deep detail of this, then you must remember this fact that E is equal to mc square tells us that mass and energy are interconvertible. Means we can destroy the mass completely to convert it into the energy and the vice versa. Energy can also be converted into the mass because there are such reactions in which energy is absorbed. Those reactions are known as endothermic reactions. You must have heard these two terms, exothermic and endothermic reactions. Exothermic reactions are those reactions in which energy is produced, and endothermic reactions are those in which energy is absorbed. So, in case of exothermic system, mass is converted into energy, and in case of endothermic process, most of the time, energy gets converted into the mass. So, mass is not a conserved quantity. Just remember this point, even if it is the fact that in most of the cases we use that mass is constant, because those cases does not involve such a situation. Have you got this point? Okay. So we were talking about the conservation of charge, which is more important to discuss in electrostatics. So by the conservation of charge, what I mean that net charge of an isolated system remains conserved. What does that mean? Net charge of an isolated system remains conserved. We cannot take the guarantee of net positive charge or the net negative charge individually, but net charge can be assumed as constant, but the system has to be isolated. I give you an example. There is a case of neutron annihilation, means we can destroy one neutron to get one beta particle and one positron, and some amount of energy is liberated. These are the gamma photons. So in the neutron annihilation process, what we get one beta particle, which is the negatively charged particle, and one positron along with some energy, which is being liberated in this neutron annihilation process. Annihilation means to completely destroy. So in this case, suppose we take it as an isolated system, then initially before the conversion, net charge is 0. What is the net positive charge? So initially it is 0. What is net negative charge? It is 0. What is the number of charged particles? As we know that neutron is not a charged particle, so number of charged particle is 0 in this case before this annihilation process actually takes place. And when it happens after that, if I ask you that what is the net charge of the system, then we know that there is one particle beta which has got the charge equal to that electron negative, and there is one positron which has got equal amount of charge of positive nature. So there has to be net charge remains 0. And what is net positive charge after this conversion? Net positive charge is plus E. E is the electronic charge. And what is the net negative charge? That is minus E. Number of charged particles after this process. There is one negatively charged particle, there is one positively charged particles. So again, just understand this fact that total charge of an isolated system remains conserved, and that is only for the net charge of the system, not individually the positive or the negative charge. So have you got this point that we can take guarantee of the net charge conservation, but in this process, as you have seen that total positive charge can change, total negative charge can change, even the number of charged particles can also change, because we have produced two particles having charge. So net charge is guaranteed for an isolated system. Okay, do you agree with me that universe is an isolated system, the whole universe? Yes, it can be taken as an isolated system. So in the universe, if we say that total charge remains constant, will it be true? Of course it will be true, because net charge of the universe must remain constant because it is a sort of isolated system. But what about the net positive, net negative, or the number of charged particles? That can always change. Means net positive charge of the universe might change, net negative charge of the universe might change, and even the number of charged particles also will keep on changing. But the one thing that remains fixed is the net charge. So have you got this whole concept of conservation of charge? So charge is a conserved quantity, and what does that mean? That net charge of an isolated system remains constant. Isolated system means the system which cannot interact with its surrounding. So net charge remains constant, not the net positive or net negative or the number of charged particles. There is another important property related to the charges. That is, there is a property of invariance. If I ask you that, do you know or have you seen this equation anywhere? M is equal to m naught divided by under root 1 minus v square over c square. M naught in this equation is known as the rest mass, and v is the speed of the body, and c is the speed of light. So according to this equation, mass of the object changes with the velocity. Although when velocity is very small, as is the case of our day-to-day life. Since velocity is very small, then the variation of mass is not felt much. And we always ignore that because that amount is something which we cannot feel at all. That is why this equation remains covered. But the fact is that when objects start moving, its mass changes, and this equation was given by the great scientist Einstein. And just see, when the speed of the body becomes comparable to the speed of light, suppose it becomes 1/10 of the speed of light, in that case variation of the mass will be significant. So this equation actually is applicable only when object is moving with very, very high speed, and that high speed which can be compared with the speed of light, say 100 of the speed of light or 1/200 of the speed of light. But in day-to-day life, we know that we don't even attain a fraction of the speed of light. That is why this equation has no meaning in our day-to-day life, and we tend to ignore this fact that mass changes with the velocity. So this property is known as variance. Means mass is variant, means it changes with the speed of the body, but charge is invariant. Means speed of the object has no effect on the magnitude of the charge. So what do you mean by the invariance? Have you got it? Okay, repeat after me. Invariance means charge of body does not change even if the body is in a state of motion. That is unlike mass. As we know that mass is variant, but charge is invariant. Charge doesn't change with the velocity of the object. So I hope you have understood this term completely, invariance. It is one of the important properties of the charges and its comparison with the mass, that mass is variant but the charge is invariant. So that's all about the properties of charge and its comparison with the masses. So in the next part of this session, we'll start with the real stuff, that how to create charged bodies. Till now, we were just saying that charges can be created by the transfer of electron and all. But in the next part of this video, we'll understand that actually how do we create charges in nature. So just watch the next clip for that.